Well, good morning, everyone. As I said, I am on my way to Texas to Baylor to watch my son's graduation. So today we're going to finish the note sheet from yesterday. So if you take that out, we have one problem I want to do from there, and then we're going to move on to the next section. This will only work if you take notes. Pretend I'm right in front of you, just like you take notes on a real day. Write down everything that we do together. So number 8 from yesterday. Find an equation of the perpendicular bisector. Well, what is a perpendicular bisector? Perpendicular bisector is if this is a segment, let's just pretend that this is 8 inches long. The perpendicular bisector, bisect means it cuts it in half. So it would be perpendicular and it would cut it in half. So like I said, if this original was 8, this side would be 4, this side would be 4, and it divides it in a way that makes a right angle. So that's the perpendicular bisector. So what do we want to do? We want to write an equation of the perpendicular bisector of this segment. So I'm just going to draw a rough picture just to help me. Nope, not sure what I'm doing there. So let's draw an axis. Hopefully yours looks better than mine. So 3, 5, I'm not even going to mark like individual markings here. I'm just going to estimate. So 3, 5, this is just a rough picture. So A is at 3, 5. B is at 9. 9 is further to the right down here. So this would be point B is at 9, negative 3. So this would be, just to help me get this straight with my pen here, I'm going to use this. So here is my segment joining those two. I want the perpendicular segment that goes, so that would be like halfway, and it would make a right angle. So this is what I'm trying to find the equation of. So we'll assume that I did that perfectly, and that is a right angle, and these two are equal to each other. So any point on here, like let's go back over to this picture. So if I were to connect from here to here and from here to here, all of those points are going to be equal. All of those segments that I draw are going to be equal. So if this is the perpendicular bisector, then what that means is that, like, if this is 5, this is 5. It's supposed to connect here, but it's hard with my pen. I know I keep saying that, but so that would be 5 as well. So any point, doesn't matter where you draw, it's not going to be 5 here, but this might be maybe 4.5, and this would be 4.5. If you draw one way down here, it might be 8 and 8 and so forth, but the distance is going to be the same. So if I pick a point out here, I'm just going to call it any point. So I'll label it XY. And if I connect those two, what's the distance from that point to there? Well, the distance, I'll just call it PA, is, using what we did yesterday, the distance formula would tell us the distance between point P and point A is the square root of the quantity x minus 3 squared plus the quantity of y minus 5 squared. The distance from P to B, well, okay, the distance from P to B, that's going to be the square root of, again, I'm just going to start with x. So that's what we did yesterday. Again, x minus 9 squared plus the quantity of y minus negative 3, which is plus 3 squared. And as we said over here, those two distances are going to be equal. So anytime you put it on the perpendicular bisector, the distance from any point to the end point, hopefully that makes sense. If you draw a decent picture, it's going to be clear that those two distances are going to be the same. These are split in half, but those will be the same as well. So the distance from P to A has to equal the distance from P to B. So now I just want to simplify this equation as far as I can. Hopefully you see that you would just square both sides to get rid of the radical symbol. So that would just give me this quantity squared plus this quantity squared without the square root. I might as well FOIL while I go here. So if I FOIL this first one, it's going to be the x squared minus 3x, that would be minus 6x plus 9. If I lost you there, just go ahead and FOIL this, write it twice, write it next to each other, x minus 3 and x minus 3. Again, the squaring cancels the square root. Now I have to do the y minus 5 squared, so plus y squared minus 2 of the same thing, so minus 10y plus 25. And that's going to be equal to, on this side, I'll do the same thing. X squared minus 18x plus 81 plus y squared plus 6y plus 9. I'll combine my like terms and so forth, but if I subtract x squared here and here, they're going to give me 0. Do the same thing with the y squareds. They're going to give me 0. So all I have left are the x's, the y's, and the numbers. So I have a 9 here and a 9 here. That makes it nice. Otherwise, I would just combine my like terms. So what's my net result? I can add 18x. You don't have to show all this, but if I add 18x to both sides, I get 12x. If I subtract 6y, I won't show that, but if I subtract 6y, I get negative 16y. If I subtract 81 on both sides, that gives me minus 56, and that's going to now equal 0 because I got rid of everything on this side. So that's how the book will leave this equation. Looks different than how we left them before, but just so your answers match what they have in the back of the book, that's how they leave that. All right, we are going to skip number 9 for today. So now if you just switch and take out the notes sheet for today, just make sure that the substitute gave you the note sheet for today. So what we're going to talk about today and tomorrow are circles. Now, you know a lot about circles, but we're going to learn more about circles. The next 4 sections are what we call conic sections. They're second degree. That means you're going to have squared. You might have both an x squared and a y squared. Secondary equations that are curves obtained by slicing a double cone with a plane. What does that even mean? I just snipped some pictures from your book. If you take a double cone, like a cone on top of a cone upside down, and just slice a plane, you're going to get different shapes. So here's one shape, not quite a circle. It would be more like an oval type. We'll learn the specific name for that. Same here. You can slice it this way. That would give you a parabola shape. You can slice it straight up and down. We'll talk about all those different shapes, but these are called conic sections. All right, so a circle is the set of all points in a plane that are a fixed distance called the radius from a fixed point called the center. Okay, what does that even mean? Okay, well, what that means is, I should have given myself more room here, but if I have a point that's called the center, and I say I want all the points that are 3 inches away. So, okay, well, here's a point that's 3 inches. Here's a point that's 3 inches. Here's a point that's 3 inches. They have to be in the plane. But if I were to take my ruler and just find all the points that are exactly 3 inches away, if I could draw a better circle with my pen here, that's what a circle is defined to be. So again, it's the set of all points in a plane that are 3 inches from a point, or 4 inches from a point, or 10 inches from a point. That distance, that 3, is the radius. Okay, so my next question is, I want to find the equation of any point that's on a circle with this center and this radius. All right, so let's draw a rough picture again. So my center is at 4, -2. Again, you don't have to put like little markings here. So over 4, down 2. So here's my center. My radius is 5, so that means it's going to go past. The picture's really not critical here, but it's going to go past here because I'm over 4, and my radius is further. So my circle is going to look much better than that, hopefully. All right, so I want any point on the circle. So I'm going to do the same thing we just did. I'm going to call this point P. And what I know now is that the distance from the center to that point is supposed to be exactly 5 inches. So the distance, so this point here, the center is 4, -2. So that distance, so the distance from C to P is supposed to be 5. Okay, let's just do what we did on the last problem. So the square root of x minus 4 squared plus the square root of, or plus y plus 2 minus a negative. So y plus 2 squared equals 5. This just comes from the Pythagorean theorem. If you forget what the sign is, again, this is just a squared plus b squared equals, and it's the square root because it's not c squared. But I can square both sides, and I'm left with the quantity of x minus 4 squared plus y plus 2 squared equals 25. There's my equation of the circle. Now, we don't want to have to do this process every time. So we have a formula that comes from just doing it in a generic sense. Like if I called this, instead of 4, negative 2, I could call the radius hk. And if I did the exact same thing with an h and a k in here, and this would, instead of calling it 5, I could just call it r, that's going to give me a generic formula. So I don't have to do that every time. So the equation of a circle with with center hk and radius r would be what we just did. To make it easier, I'm just going to write it basically as the Pythagorean theorem. So instead, I'm going to get rid of the square root like we did in our last step. So again, this is really just a squared plus b squared equals c squared from yesterday. So let's see how easy this is. Find the equation of the circle that has this center and this radius. So my equation is simply x minus the x coordinate of the center. So that's going to wind up being plus 3 squared plus the quantity of y minus 4 squared equals the radius squared. Again, let's go look back at that equation. You have it, the formula, you have it right on your paper. But it really is coming from the distance formula. It's coming from the Pythagorean theorem. It should be easy to remember. Equals r squared. So that would be equal to 6 squared, and I'm finished. All right, number 3, I just wanted to do one where my point has a 0. Sometimes people get confused. So this would just be the quantity of x minus the x coordinate of the vertex. That's going to be plus 8 squared. And then this is just y minus 0, which is just y squared. And then the square root of 7, this is always r squared. So this is going to be the square root of 7 squared. So it's just regular 7, the square root of 7 squared. Easy enough. All right, the last two are just slightly different. So now they're asking me to graph this circle. Okay, well, what I can do is make it look like a circle formula. So I'm going to square both sides. Let me write it again. So I'll square both sides. Again, that cancels the square root. So I get x squared equals 36 minus y squared. I'll add y squared to both sides. So what it looks like I have right now is a circle that has center 0, 0. Like if I go backwards from here, you should be able to look at this and say, okay, well, if I gave you this equation, if I'm not given what I have up here, so if I'm given this, you should be able to identify easily the center and the, let's get rid of that, and the radius. So from here, I know my center is 0, 0, and my radius is 6. Except for one big point. The square root of 36, well, let me pick a different number here. So the square root of 4 is just 2. So remember, if I have an equation where I have x equals the square root of something. Sorry, let me just make this easier here. If I have the square root of x, I know that x has to be greater than or equal to 0. I can't have the square root of a negative. So I can't have like the square root of negative 4. We're only graphing real numbers here. So we're not graphing imaginary numbers. So way back in the beginning, the original problem, this will only give me positive or 0. There's no way to get a negative. So what this is going to look like, my radius is 6, so I'll go over 1, 2, 3, 4, 5, 6. I'll go left 6, and I'll go up 6. But there's no way to get any points down here. So all right, so these last two are a little bit different. Now, before I do this problem, well, let me write it again. Hopefully you see that I can square both sides to get rid of my radical. So if I square both sides here, squaring gets rid of my radical. So I get x squared equals 36 minus y squared. Add y squared. And this is easy to see that this is just going to be a circle with center 0, 0. Like if I go backwards from here, like if I give you the equation, you can just go backwards and identify the center and the radius. Like that should be easy to go back and forth. So I can look at this one and easily see that this would be a circle with center 0, 0 and radius of 6. But if I try to draw those, if I start drawing those points in, so I have a point 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, and then go down 1, 2, 3, 4, 5, 6, and make my circle. But don't do that yet, because we need to remember something important about radicals. If I have x equals the square root of something, like the square root of w, we learned a long time ago, if we're graphing, now if it's not graphing, then you can have imaginary numbers, but this can't be negative. Otherwise, we won't have a graph. Imaginary numbers don't show up on a graph. So w has to be greater than or equal to 0. There's no graph. Like if this is the square root of -4, it's not going to show up on a graph. So x, so this value here can be 0 or it can be positive. So x can either be 0 or positive. So y can be, again, you can put in different values for y, but once you plug it into the square root and so forth, you're never going to get anything that's going to wind up being a negative result. So if I take the square root of 0, I get 0. If I take the square root of a positive, I get a positive. So x goes left and right. Okay, so x goes left and right. So if I'm thinking x has to be positive, that means like this whole side of the graph, there's never going to be anything here. So let's get rid of this dot that we have right here. And all I'm going to have, and I'm going to do the best I can, yours will look better, just try to draw a nice curve that hits that point and so forth. So it should be like a circle. But instead of having the entire circle, again, x has to be positive. X goes left and right. Now, if it was y, then that would go up and down. But this one was x, so it would go left and right. So that would be my picture. That would be my graph for that. And the last one, go ahead and put a 9 in here. So let's just pretend it was equals 9. So x squared plus y squared equals 9. I know that my center is 0, 0. And my radius would be 3. So that picture is easy. 1, 2, 3, 1, 2, 3, 1, 2, 3. 1, 2, 3. But those would be the points that would be exactly equal to a radius of 3. Those would be exactly equal to 9. So those would have a radius of exactly 3. We want the distance, that's what this deals with. We want the distance to be more than a radius of 3. We want that number to be bigger than 9 up here. So we want the radius to be bigger than 3. So what I'm going to do is draw a dotted circle, just like a dotted line you would graph. And then I want all the points that would have a radius bigger. Like if this is, let's say this is 16. If that's 16, you'd have a radius of 4. If it's 25, you'd have a radius of 5. So I want all the radii that are bigger than 3. So my picture is just all the points outside of that circle. Now you can just draw it like you can make like a, get rid of this here. So you can just like shade this area in like I'm doing here. But make sure it's a dotted because it's just greater than. If it was less than, we would want the radii to be smaller. All right, use your notes to help you. You can obviously rewatch any parts of the video. Your homework is here. This will be posted. The even answers will be on a PDF as well. Have a great day. I will be back tomorrow with part 2 of circles.